Hello and welcome. In this video session, we will learn the Lseek system call and we will see how to use the Lseek with few examples. A file can be considered as a continuous set of bytes. There is an internal indicator present which points to the offset byte of the file. This offset is used to read or write the next set of bytes or data from the file. This indicator is updated when we do any file operations like read or write. Lseek is a system call that is used to change the location of the read or write pointer of the file descriptor. The location can be set either in absolute or relative terms. Now let's see the syntax of Lseek. In order to use Lseek, we have to include unistd.h, and the syntax is as follows. It takes the file descriptor and the offset, and it has a parameter whence. We will discuss these parameters. So when the Lseek fails, it returns a -1 on error. So we can consider this as a file with some data in it. So we have a offset indicator which keeps on changing its position based on the read and write system call. Seek set refers to the initial offset of the file, and seek end refers to the end of the file. Now let's go back to the syntax of the Lseek. So in this Lseek, we have to pass the file descriptor. FD represents the file descriptor of the file, and next will be the offset. So offset refers to number of bytes that we need to travel. For example, there is one more parameter called as whence. The whence can take one of the three parameters like seek set, seeker, and seek end. So when we give seek set, then the number of the bytes that the internal indicator points to is 0 plus offset. That is nothing but it points to the offset indicated in the Lseek. So for example, let's say that we have given offset of 10 and we have given seek set as a parameter in whence. So now after we call a Lseek, the internal indicator points to the offset byte, that is nothing but the 10th byte. Next, let's see how seek COR works. When we specify the parameter seek underscore cur, so the number of the bytes offset occurs is from the current position of the offset plus the offset given in the system call. For example, let's say that our current offset is somewhere here in the middle of the data, and if we specify seek cur and give offset equal to 5, then the indicator shifts to 5 location from the current offset. And similarly, if you specify the parameter seek end, the offset is set to size of the file plus offset bytes specified in the system call. When Lseek fail, it returns a -1. In this example, we will see how to use Lseek system call and the different parameter that needs to be passed. Here we include the required header files, then later open the file called input.txt in read-write mode. In case of an error from the open system call, we exit the program. Now we are going to perform the Lseek. Now the Lseek is being performed initially on seek set to 0 bytes, and later seek set to 2 bytes, and later we are performing Lseek on seek cur to 6 offset bytes, and we are reading the contents from the new offset position and finally traveling to the end of the offset of the file and appending some new data. Let's compile this code, run the program, and analyze the code line by line. Now let's compile the code using the GCC compiler. We have got the output file Lseek, and let's see the input file. The contents of input file is something like this is example of OTrank. This is a input of the input.txt. Let's print the input on the screen for reference. So now we are going to run the object file that we have obtained from compiling the code. After running the program, let's analyze the output. The initial offset position is 0. So this is from this line. So initial offset is 0 because we have given a seek set here. So seek set travels from the beginning of the file to 0 bytes and returns back the new offset value. Now the new offset points to the 0th byte of the file. Next, the offset position is 2. We have got the output. That is nothing but after performing a Lseek of 2 bytes from seek set. That means whenever we give seek set, it refers to from the beginning of the file travel the bytes mentioned in the parameter. So now from the beginning of the file we have traveled 2 bytes. So the new position, seek position, would be 2. That's the output what we have got. Next, let's analyze this output. Seek position is 8. Now we have called the Lseek with parameter as seek underscore cur and given a offset byte of 6. This means from the current offset travel to 6 bytes. So the current offset in this case was 2. So 2 plus 6 is 8. So the new offset now points to byte 8. So now after the offset is pointing to new location, we are going to do a read system call and we are going to read the 10 bytes of data and copy it into the buffer. So after reading the data from the input.txt, we are going to print the buffer here. So read bytes are as follows. Let's see, the read bytes are as follows. So example of is the data that is being read from the file. So if you see here, we are getting this string from the input.txt. This means the read starts from the 8 byte and gets the next 10 bytes of data from the file. So now next we are going to perform a Lseek and travel to the end of the file. So the seek end specifies the offset to end of the file and we are going to print the new seek position. That is this is nothing but it points to the end of the file and the position is 65. So now after going to the end of the file, we are going to append the new data. So here the new data is copied to the buffer and written to the file using the file descriptor, and finally we close the file. So now let's check the contents of the file. So here this was the original content and we have appended the new data. This appending of new data is performed after traveling to the seek end. So the seek end has traveled to the end of the file and after this, when we write a new set of data, it has appended to the end of the file. So this seek end can also act as a append flag. Okay, so one more point to mention here is whenever we open any file, we get the file descriptor, then we perform the operations like read, write, Lseek, whatever we have to perform. Then finally we need to close the file. So the closing the file will return the file descriptor that we have obtained previously to the system, and this file descriptor can be used to open any other new file.